Okay, second part of the video covering confidence intervals now. So exercise 31. A survey of 700 non-fatal accidents showed that 143 involved faulty equipment. What's a point estimate for P? A point estimate for the population proportion is P hat, which is the sample proportion. To find the sample proportion, guys, you just divide 143 divided by 700. That's all. Same thing for 32. A survey of 250 households showed that 91 owned at least one snowblower. What's a point estimate for P? It is P hat, the sample proportion, just 91 divided by 250. 33. Find the margin error of the given values. So he gives you the confidence level, he gives you the population standard deviation, and he gives you the sample size. The margin of error would be E equal ZC, which is the critical number, times sigma divided by square root of n. I do provide the formulas if you need them. Okay, sigma is given here, which is the standard deviation, 11.5. N is 120. All you need to find ZC based on the 90%. For 90%, Z is 1.645, but I'm going to show you guys how to find this value, either using the normal calculator or using another program built on StatCrunch. Let me show you how to do it with the normal calculator. So just go to between, put 0, 1, we're back to Z, and put right here 90%, 0.90, and you get the critical numbers. So for confidence interval, when it comes to Z, see the critical number, you just go to the normal calculator, select between, put the confidence level right here, and then it's going to show you the two critical number. There's one here, and there is another one right there. It's 1.645. Okay, so we go back to the sheet now. 1.645 times 11.5 divided by square root of 100. Next question. A group of 49 randomly selected students has a mean age of 22.4. That's X bar. So N is 49. X bar is 22.4. And the population standard deviation, he gives you the population standard deviation. If he gives me sigma, you must use Z stats. You must use a Z distribution, the standard normal curve. Construct a 98% confidence interval for the population mean. So let me show you how to do that using StatCrunch. So you just go right here. Okay, I don't need this now. We go to stat. Z stat, when he gives you population standard deviation, you must use Z stat. One sample with summary. You enter the sample mean, which was what, guys? I forgot. 22.4. The standard deviation is 3.8. The sample size is 49. And the confidence level, he wants 98. And look, if you want the critical number, you don't want to use the table, just select here, select show critical value, compute, and look, guys, this is the interval, 21.14 and 23.66. And look, this is the critical number, 2.33, if you round it to 2 decimal places. How do you interpret your answer in words? You say, with 98% confidence, we can say that the true mean is between 21.14 and 23.66. Next question. The standard IQ test has a mean of 96. So that's X bar. And a standard deviation of 14, that's S. or sigma, the standard deviation. We want to be 99% certain that we are within 4 IQ points of the true mean. So here he wants the sample size. There's a formula for the sample size that I will provide. So the sample size, when we're trying to estimate the mean, this is the formula. N equals ZC times sigma divided by E quantity square. Sigma is given 14. Margin of error, anything, guys, that comes after the word within is the margin of error. So the margin of error 4. So we know sigma, which is 14. We know the margin of error is 4. Now we need to find Z. To find Z, you can use the normal calculator, 99%, or try to memorize this one for 99% is 2.575. Let me show you how you can use the normal calculator to do it. So let me close this one. Just go to stat, calculator, normal, 0, 1, put the 99, put between, and then put the 0.99 right there. And compute, and look, these are the numbers, 2.576. You can use that one. That would be your critical number. So 2.576 times 14 divided by 4 quantity squared, and then you have to round up to the next whole number. Whatever n you get, if you get a decimal, you round it up. 36. Find the value of E, the margin of error for confidence level is 95, n is 15, and S is 5.6. So now he's given us the sample standard deviation. How do you find the margin of? Okay, so for the margin of error E, this is the formula TC times S divided by square root of N. We have N is 15, we have S is 5.6, all you need TC. You can use the table for the T distribution to find the value of T, but since I said I'm going to show you how to use StatCrunch for this, let me show you how to use StatCrunch. You don't go to the normal calculator. This is T now. It's not the normal calculator. The normal calculator is for Z. So remember, N is 15. So what's the degrees of freedom? Degrees of freedom is N minus 1, so will be 14. And the confidence level is 95. Let me show you how to do that using StatCrunch. Okay. You go to Stat, Calculators, T calculator. Between, because we're doing confidence intervals. What's the area? 0.95 confidence level. What are the degrees of freedom, guys? You have to put this one right here. Degrees of freedom is, with the sample size is 15. 15 minus 1 is 14. Just put 14. And the critical number is 2.145. So you just go back now to your sheet. 2.4145 right here. S is times 5.6 divided by square root of 15, and that should give you the margin of error. Number 37. In a random sample of 28 families, the average weekly food expenses was $95.60 with a standard deviation of 22.5. Determine whether a normal distribution or T distribution should be used, or whether neither of these can be used to construct confidence interval. Assume the distribution is normally shaped. Since the sample size is less than 30 and he didn't give me population standard deviation, we use a T distribution here. T distribution is the most common one, guys. Most of the problems, most of real life situation, we end up using T distribution. 38. A random sample of 10 parking meters in beach community showed Okay, next question. A random sample of 10 parking meters in beach community showed that the following income for a day. Assume the incomes are normally distributed. Find a 95% confidence interval for the true mean. First of all, you have to put the data into StatCrunch, and then I'm going to show you how to construct the interval. It's very straightforward. So let's do it. I put the data already in StatCrunch. So you go to Stat, and then you go to T-Stat. This is the most common one. One sample, but this time with data. My data is in variable 3. Choose the confidence level. And if you want the critical number, guys, you can select it from here and compute. And here's the answer. So, how do you interpret the answer in words? With 95% confidence, we can say that the true mean income of a parking meter is between $3.39 and $6.01. It's as simple as that. And look, this is the critical number, guys. You got it already with the confidence, but you don't need it since you are using StatCrunch in here. Next question. When 440 junior college students were surveyed, 200 said they have a passport. Construct a 95% confidence interval for the proportion. Okay, so we have, this is X, this is the number of observations, N, 200 is X, the number of successes. And we're gonna put them accordingly, so let's go to StatCrunch. Let me close this one. So you go to stat, proportion stat. That's the only feature that you have for proportion. One sample with summary. Number of successes is X, the smaller number, 200. Number of observation is 440. Confidence level is 95%. And if you want the critical number, just put it there if you want to. And this is the interval right there. So you say, with 95% confidence, we can say that the true proportion is between 40.8% and 50.1%. Okay, so that's how it's straightforward. And you remember the 95% confidence has a critical number of 1.96. Look, it shows me the number right here as well. Next question. 41. It's about sample size now. A pollster wishes to estimate the number of left-handed scientists. How large a sample is needed in order to be 95% confident that the sample proportion will not differ from the true proportion by no more than 6%. The 6%, guys, is E. The difference between the sample proportion and the true proportion is always the margin of error, so that's E, 0.06. A previous study indicated that the proportion of left-handed scientists is 9%. That's P hat. Now, for the formula, we need a P hat, we need a Q hat, we need Z, and we need E. If a P hat, guys, is 9%, then Q hat is 1 minus P hat. So it will be 1 minus 9% will be 91%. E is 0.06. We need Z. Z, what's the confidence level here? 95%. If you memorize it, it's 1.96. But if not, you can get it from StatCrunch. Watch. You just go to Stat, Calculators, Normal. Since it is about Z, we can go back to normal. Between, put 95 right here, guys, 0.95. And hit compute, and you're gonna get 1.96. If you look at your table, the standard normal table, you see that the bottom, it tells you if the confidence level is 95%, the critical number is 1.96. I would try to memorize this one. So you just put 0.09 times 0.91 times 1.96 divided by 0.06 square. And if you get a decimal, you round it up. Number 42. Find the critical t value that corresponds to 95% confidence interval, and n is 16. You have to use t here. You have to use the t calculator. So if I take you to the t calculator, guys, I'm just going to close this one. T stats, and sorry, calculator t right here. Okay, the sample size is 16. So what's the degrees of freedom, guys? Is 15. And what does he want? Let me just make sure. 95. So just go to between and put 95 right here. and hit compute. And the critical number T is 2.131. Don't put 16 here. It says DF. DF means sample size minus 1. Next question. Suppose a 90% confidence interval for the mean turns out to be 1000 to 2100. If this interval was based on a sample of size 25, explain what assumptions are necessary for this interval to be valid. Remember, guys, if the sample size is less than 30, we require the population to be normally distributed. So that's a requirement that we need, the assumption that we need to make. 44. Construct a 95% confidence interval for the mean. Assume that the population is normally distributed. A sample of 20, so that's n. That's the sample size n. Part-time workers had a mean annual earnings, so that's x bar, 3,120. With a standard deviation S of 677, find the confidence interval. So that's a T stats. Unless if he gives you population standard deviation, you use Z, but it's always T, guys. So let's go and do it. Close right here. I don't need this. I don't need that. We go stat, T stat, one sample with summary. Sample mean is 3,120. Sample standard deviation is 677. Sample size is 20. Confidence level is 95%. And if you want a critical value, you can show it. And here's the answer. So you say with 95% confidence, we can say that the true mean annual income is between of part-time workers is between $2,803 and $3,437. Okay. 45, construct a 99% confident interval population mean. Assume population is normally distributed. The reason why he say make this assumption, guys, because he gave me a sample size less than 30. If he gives you a sample size less than 30, we must have the original population must be bell-shaped. So here n is 19, x bar is 22.4, standard deviation S is 3.8, and you just run the test at 99%. T-stats again. One sample with summary. 22.8, 3.4. Is it 3.4? Let me look. 22.4 and 3.8. Sample size is 19. And what confidence level he wants? He wants 99%. So you say with 99% confidence, we can say that the true mean is between 19.89 and 24.91. Next question. The grade point average of 10 randomly selected junior students are listed below. Assume that the grade point average are normally distributed. Find a 98% confidence interval. Okay, I'm not going to do this one, guys, but this is what you're going to do. You're going to put this data into StatCrunch. So let me just go there. So assume that this is the data right there. And you just go to stat, T-stats. It's always when he gives you data sets, it's T-stats. One sample with data this time. You selected from right here the data, and then you choose 98. Don't forget to select the confidence interval here, 98. And then you hit enter, you will get the interval. The lower limit is the lower bound, and the upper limit is the upper bound of the interval. Next question. Let's see. The number of wins in a season for 32 randomly selected professional football teams are listed below. Construct a 90% confidence interval. Again, guys, you have to input this data into StatCrunch. Let's say put it under variable 1, for example. And then you can do the following after you do that. So you just go to StatCrunch. Let me cancel here. Let's say you put the data right here. I'll delete it from here. So you put it right here. 32 values. You have to input 32 values. And then you just go to stat, tstats, one sample with data. You select the column. You select the confidence level, which is 90% right here. And then you will get your interval. Just hit compute. Okay, so I don't need to do this one. 48. In a random sample of 60 dog owners enrolled on obedience training, it was determined that the mean amount spent per owner is $109.33, assuming that the population standard deviation. Since he's giving you the population standard deviation right here, guys, you cannot use T, you must use Z. Of the amount spent is $12, construct and interpret a 95% confidence interval. So in order to construct a 95% confidence interval for the mean, we need to use Z-stats because he gave me population standard deviation. The only time you use Z, guys, if he gives you population standard deviation. So if we just go there, let's cancel here, stat, Z-stats, one sample with summary. Sample mean is 109.33. The standard deviation is 12. Sample size is 60. And he wants a 90% confidence level. If you want to select this, that would be fine. Compute. Interpretation. With 95% confidence, we can say that the true mean cost to train a dog is between $106.29 and $112.37. Okay, that's how we state the conclusion of the confidence to interpret the confidence interval. 49, a doctor at a local hospital is interested in estimating the birth weight of infants. How large a sample must she select if she desires to be 90% confident that her estimate is within 2 ounces of the true mean? The 2, guys, is E, the margin of error. Now he wants the sample size, so you have to use the formula for the sample. So the formula is N equals ZC times sigma divided by E quantity squared. E is 2, guys. S or sigma is 5. All we need to know Z. And for 90%, Z is 1.645. And I did show you how to find this one. If you want to see it again, you can use the normal calculator to find it. Since it's about Z. Normal means Z. So you just go between and you put 90% right here and hit compute, and it's 1.645. In your table at the bottom, it says for a confidence level of 90, the critical number is 1.645. So we just go back to the sheet. You put 1.645 right here, times 5, divided by 2 square. And remember, guys, you're going to get a decimal. You round it up to the next whole number. The last question. A researcher wishes to estimate the number of households with 2 cars. How large a sample is needed in order to be 95% confident that the sample proportion will not differ from the true proportion by no more than 5%. That's E, as I explained earlier. When he mentioned the difference between sample and true proportion, he's referring to the margin of error. Or anything that comes after the word within is the margin of error. So E is 0.05 here. Previous study indicate that the proportion of households with 2 cars is 22%. That's a p hat, guys. That's the sample proportion. The formula. Here's the formula. N is p hat. Q hat is 1 minus p hat. Your book probably put 1 minus p hat instead of q hat. Times z divided by e quantity square. P hat is 0.22, so you put 0.22 right here. 0.22. So n would be 0.22. Where did we get 0.78 from? 1 minus 0.22 will be 0.78 times z at 95%, guys, is 1.96 divided by 0.05, which is the margin of error square. If you get a decimal number, you round it up. For example, if you get n equals 233.4, your answer should be 235. That concludes the review of this